On Tomorrow's World Today, we explore the cutting-edge advances that are shaping 4 different worlds. The world of inspiration, where the wonders of the natural world amaze and inspire us. The world of creation, where ideas come to life from traditional arts. The world of innovation, where ideas and inventions move us all forward. The world of production, where innovations are mass-produced to improve our lives. From Inventionland World Headquarters, here's your host, George Davison.
Hi everyone, I'm George Davison. You know, the goal of any innovation is to make existing products better. And the evolution of heating and cooling systems in America is an excellent example of progress over time. The 19th century introduced us to radiators, which brought consistent warmth into our homes and workplaces. With radiators, the concept of central heating began to take shape. And then, in the 20th century, we ushered in a technological revolution. From systems that circulated warm air through ducts, to ventilation and air conditioning systems that brought relief from scorching outdoor temperatures. The boundaries of comfort were stretched. This changed how we lived, worked, and interacted within our spaces. Today, the demand for cooling is increasing. But how do we meet this rising need and keep sustainability and energy efficiency in mind? We meet it with innovations that digitally connect buildings and with the growth of solutions that allow us to store energy. Imagine a system that doesn't just heat and cool in real time, but also stores extra energy for when we need it the most. I'm sending Greg, our field reporter, to the world of innovation in the Twin Cities. I heard there's an emerging technology that's going to change the way we live.
Humans, we love to be comfortable. But as we look at the challenges that we face in today's world, we have to make choices around that comfort that prioritize sustainability. I'm at White Bear Lake in Minnesota to meet with John Sustar and the experts at Trane Technologies to discuss some exciting and innovative ways that we'll stay comfortable responsibly in tomorrow's world. Hi, John.
Hey, Greg.
Good to see you.
Good to see you.
So, John, we've all heated and cooled our homes for such a long time. We kind of take it for granted. We really don't think about the energy use involved or the environmental impact. Tell me more about that.
Yeah, so cooling in buildings is complex. And it's complex because there's a wide variety of building types out there, from hospitals, schools, retail stores. But these cooling systems in buildings are energy hogs. You know, heating and cooling systems typically account for 40% of the overall energy consumption in buildings. And that energy usage translates into environmental impacts in a few different ways. One of the largest ways is the carbon emissions associated with that energy, whether that's coming from the electric grid or coming directly from the equipment. And we're helping our customers reduce their environmental impact by improving the energy efficiency of their buildings.
That's great. Obviously, reducing that impact is key, but you have to keep the humans in the building comfortable as well.
Yep, so keeping the people comfortable in that building is key because, you know, if they're not comfortable, they're not going to be productive.
Right. What are some of the other cooling needs that a building might have?
Yep, so comfort cooling is only a part of the energy equation for cooling in buildings. There's other applications out there that are even more intensive from a cooling standpoint. One of the fastest growing markets out there for cooling is data centers.
From an energy standpoint, what would be the difference between a regular building and a data center?
Yeah, so data centers are among the most energy intensive building types. They often consume 10 to 50 times more energy per square foot than your typical office or commercial space. And the cooling systems within that building is about 40% of that building's energy usage.
What would some of the consequences of not keeping your data center cool?
So those server rooms in data centers emit a lot of heat. And if those data centers aren't cooled properly, that leads to downtime and that leads to potential network failures. And there's lots of organizations out there, from hospitals and schools and banks, that depend on reliable networks. But believe it or not, the same equipment that we use for cooling can also be used for heating. And we're scaling that technology up to make buildings even more sustainable.
So this sounds like technology we might see around our homes, but on a much larger scale.
Yep, so the technology is called heat pumps. Heat pumps have been around for decades, but we're starting to see a resurgence in this technology due to innovation, making this technology more capable. Also, they offer us a way to move from fossil fuels into electrified heating. But because of their name, heat pump, people may not realize that heat pumps not only heat, but they can also cool. And they do this by moving heat from one place to another. When they're operating and heating, they're moving heat from the outside of the building and moving that heat inside. And they can even do this when it's really cold outside. When operating and cooling, they're moving heat from the inside of the building to the outside of the building.
Well, what would be the advantages to a heat pump as opposed to a more traditional system like a boiler?
Yep, so boilers create heat, whereas heat pumps move heat. And that process of moving heat from one place to another is a lot more efficient. It takes 1 unit of energy to move 3 units of heat, which effectively makes this technology 3 times more efficient than your traditional boiler.
Okay, well, I mean, is there someplace maybe in town where we can get a look at how this technology works in action?
Just down the road, there's the Science Museum of Minnesota, and they're using our cooling equipment to also do heating.
Let's take a look.
Sounds good, let's do it.
Heating and cooling are essential to our everyday lives, and they have to run sustainably. So far, we've explored the difference between cooling for people and cooling for equipment. Now it's time to see just how efficient it can be. John, this is an amazing facility.
So here at the Science Museum of Minnesota, there's lots of visitors, and we need to keep these visitors nice and comfortable. But we also have to preserve the artifacts here in the museum. This is Patrick Hamilton. He's the manager of sustainability initiatives.
Well, Patrick, the museum's been around for a while. Have you always used this kind of efficient heating system, or is this relatively new for you guys?
Sure. Back in 2010, the Science Museum contracted with a consulting mechanical engineer to do a top-to-bottom energy analysis of this building. Several months later, he came back with his report and he said this building was using 6.5 million kilowatt hours of electricity annually. I'm not an engineer, I'm not a facility manager, but I am a geographer. So I put that in terms that I could understand. What he was saying is that this one building in 2010 was using as much electricity as all 300 households in an 18-block area of St. Paul.
Wow, well, how exactly does the system work?
Well, under his recommendation, we purchased and installed 2 devices called heat recovery chillers, a fancy name for a big commercial-scale heat pump. Think of your refrigerator, which takes heat out of the compartment and then dumps it into the air in the kitchen. These devices take that heat energy that they extract from the compartment from the Science Museum, and we use that heat energy to warm the fresh but cold air that we bring in all winter long.
How exactly is all that heat generated?
Well, our bodies generate heat, but also all the electricity coursing through the Science Museum, it eventually degrades into heat. And prior to doing the heat recovery system, we expelled a lot of that heat energy to the environment.
How has that raised the efficiency of the facility?
Well, depending on the severity of the heating season, we've been able to cut our purchases of hot water by 35 to 60%.
Wow, and I know that what we look at, what we see here is really only a small part of the Science Museum of Minnesota. You're actually charged with taking care of a large number of artifacts.
That's right. 2 million artifacts we have the responsibility for maintaining in perpetuity. And we need to maintain very narrow humidity and temperature controls on those objects, much more narrow than the public at large, which is quite challenging given the extremes of Minnesota's climate from cold to hot, from winter to summer.
So, John, this sounds to like an immediate use kind of situation where the air comes in, they warm it, and then bring it back into the museum to be used to keep people comfortable or to keep the artifacts protected. But it seems to me that as efficient as that is, we could really even raise the efficiency more by storing that energy for later use.
Yep, absolutely. And now we're using thermal energy storage battery systems. And systems like this that do heating and cooling are becoming even more efficient. Let's go back to White Bear Lake and I'll show you one.
Sounds good. Thank you, Patrick.
Thank you.
Thanks, Patrick.
Thank you.
So Greg, think of this system as having a battery, but instead of storing electrons in these batteries, we're actually storing cooling and heating for later use depending on the building's needs.
Okay, well, how exactly does it do that?
Yep, we've got a chiller that actually can make ice within each of these tanks. Each tank consists of 1,600 gallons of water, which changes phase from water to ice and back into water. When they have ice in the tanks, we can actually store cooling in those tanks to provide cooling for the building. And by a byproduct, we're actually melting those tanks and turning those into water. When they're filled with water, we can actually source heat from that water and provide heating to your building with the use of a heat pump or a heat recovery chiller. And by doing that, we're actually refreezing those tanks back into ice.
Okay, well, how much energy does each of these tanks hold?
Yep, so each tank consists of 2 million BTUs of cooling, which is enough cooling to cool 4 2,000 square feet houses for an entire day.
What are some of the other benefits to installing a system like this?
Yeah, so there's several benefits. The number one benefit is that it improves the business's bottom line. There's utility incentives to encourage businesses to use their energy during off-peak times instead of peak times. And by building ice during those off-peak times, the company actually will save costs on their utility bills because they're not consuming energy during those peak times.
Right, well, I would imagine having a thermal storage unit like this would be great to integrate into a system that maybe uses renewable energy sources.
Yep, so thermal energy storage is a great way to supplement renewable energy sources such as wind and solar, which aren't continual generation of sources. So by storing that energy into thermal energy batteries like these, that actually makes the utility grid more resilient and lowers the carbon emissions on the grid.
So far, we've explored the science behind cutting-edge thermal energy storage and the benefits of chiller plants. But how do you integrate yesterday's cooling systems into tomorrow's world? John, a company's ready to upgrade their HVAC system. What are some of the resources that are available for them to figure out exactly what the best thing to do is?
Yeah, so there's lots of resources out there. One really important resource is energy modeling software. So Trane makes an energy modeling software called Trace 3D Plus. And this allows a customer, a building owner, to model their building and to evaluate different systems and compare and contrast each of those systems in terms of how much energy and how much environmental impact those systems have.
Okay, well, say this is a business that isn't ready to overhaul their entire HVAC system. They want to just integrate some new controls into that. Can Trane help them with that?
Yep, so by doing this energy modeling or using other tools that Trane has, we can actually decipher which of the actions is going to have the most impact and most economic sense for the company.
Okay, well, we talked a lot about heat pumps and the way they are used to cool and heat buildings and such. Are there other sort of energy sources that can be used along with that?
Yeah, so we talked about air source heat pumps, so pulling heat out of that air and putting that heat into the building. But there's other sources of heat out there. For example, geothermal allows you to pull heat out of the ground, or maybe you want to pull heat out of wastewater or a lake. So you can source heat from different sources and actually pull that heat into the building in order to heat that building.
Well, I mean, we're talking about a lot of systems here. Things are starting to get a little bit complicated.
Yeah.
And I want to know how you integrate all of this and control it.
So I've set you up with Jane. She's our controls expert, and she's going to walk you through how all these systems work together.
Excellent. Hi, Jane.
Hi, Greg.
Well, John and I talked a lot about different systems, and I want to know how they all work together. And he says you're the expert on control.
Well, there are millions of pieces of heating and cooling equipment in buildings around the world. And the real opportunity is to connect them through equipment controls, which really act as the brain.
Okay, well, say I have a business and I'm not in a financial position to upgrade my entire HVAC system all at once. Would integrating one of these control modules into my existing system provide me with any benefits?
Yes, many companies take a phased approach. In fact, only 2% are really considered high-end smart buildings, so that's a lot of opportunity out there for upgrading buildings.
Well, I imagine if you have a large office building, you have hundreds of offices, even a small change could have a big impact.
Yes, just by upgrading controls, you can take advantage of the technology to help you really dial in that energy optimization. And a small improvement can have a huge measurable impact across 100 office spaces.
Give me a real-world example of an older system that's being kept relevant by the use of one of these control modules.
Yeah, we work with a hospital in Canada that's had a train chiller for 40 years, and just through ongoing maintenance and control updates and modernization, we expect to extend the life of that another 10 years.
Well, I'd really like to see this all in operation. Is there any way I can get a look at that today?
Yeah, let me send you over to meet Susie. She's got a great demonstration plan for you.
Hi, Susie.
Hey, Greg.
So Jane was telling me about all the different systems that might exist in a building. She said you could tell me how they all work together.
Yeah, so this is our Train Solution Center. This is where we bring our customers in to demonstrate how these different systems get pulled together in a single user interface.
Excellent. Well, how do we get started?
So most buildings have secured access, and you'd badge in the morning, and the building responds to your badge like this.
Okay.
Let's take a look.
Wow, okay, Susie, so the room knows we're here.
Right, so there's a bunch of sensors in this space that are determining whether or not somebody is occupying it to turn on the lights, to turn on the HVAC system, as well as some of the other systems within the building.
Okay, so now, as we look at this screen, is this the kind of thing that maybe a building supervisor or an operations manager would use to control all the systems within a space?
That's exactly right. So we can look at a particular floor in a building, we could look at multiple buildings and pull all that together in one user interface. So this is kind of a macro view of the building. In this case, we have a hospital where they can look at all the different spaces to make sure that the control system is working as expected.
Okay, now this is the whole building. Can you look at individual rooms within that space?
You can. So you can see that we have lighting indicators, security, HVAC status, and then we can also go ahead and zoom into a particular space. In this case, we have a surgery suite. So we can look at the different parameters and the statuses within that space.
So is this the kind of thing that a building manager would have to handle, or could other staff members maybe have access to this system as well?
That's a great question. You know, our building managers aren't going to be on site 24/7, so they can either schedule this in advance, or they can access the system remotely with a mobile app, so they can make some adjustments as they go.
Okay, could also a nurse maybe prepare this surgery suite?
That's exactly right. So sometimes we have non-technical users that need to interface with the system, and in that case, we can have a nurse maybe set this room to occupied mode so that it does get conditioned in advance of a surgery.
Okay, and whenever it's not being used, you can shut it down and save energy that way.
That's exactly right.
Okay, now this is all very specific, all very, you can get pretty granular in the way that this is all controlled. What are some of the goals and where is this going as we move forward?
Yeah, from a technology perspective, we think that artificial intelligence is going to start supplementing our control systems. And the reason for that is to continue to refine the energy savings opportunities that our customers might have. Basically, what that means is we're taking data from the system, both the occupancy as well as the way that the system reacted in the last couple of days, along with outdoor weather conditions. We take all that data and pull it together to automatically optimize the building. And in that case, it's really an energy saving opportunity.
Excellent. Well, this has been really exciting. Everybody at Train Technologies has been great. Scott's going to get together with George, and I've got to get back to Invention Land.
Thank you so much for coming. Let me show you out.
Hey, Scott, welcome to Invention Land.
Hi, George. Thanks for having me.
You bet. What's that?
I have something for you here. It's an all-electric, high-efficiency chiller made out of building blocks.
Very nice.
Yeah, I thought your visitors might like to hold something in their hand, even though these systems sometimes are gigantic.
No, they are. They're too big to hold in your hands, right?
They are.
Oh, that's going to go really well. I'll put it right in the museum where all the kids are coming down.
Good.
Well, I'm glad you're here. You know, Invention Land, we're all about innovation and the world of tomorrow. So can you talk with me a little bit about Train Technologies and where we're headed?
Yeah, well, Train Technologies is focused on innovations and inventions that help these systems use less energy in buildings, because today the systems use about 40% of the energy in a building just to heat and cool the space. And that's too much.
Yeah, that sounds like a lot. Is that a short-term, long-term goal? Where are we here?
Yeah, we do have some short and long-term goals. One of the things we're focused on now is something we're calling the Gigaton Challenge.
Well, so a gigaton, that sounds huge, Scott.
It is huge, but it really means 1 billion metric tons of CO2 emissions that we want to reduce from our customers' operations by 2030.
So 1 billion, okay, can you put that into perspective for me?
1 billion metric tons is equal to 100 billion gallons of gasoline. It's also equal to 200 million vehicles on the roadways.
That would be fantastic.
It's gigantic, and it's a big goal for 2030, but we're not stopping there. Our next focus is on building net zero heroes, which really is all of us, our customers, our employees, community members, even you.
Hey, count me in. I want to be one of those, a net zero hero.
That's it. Thanks, George.
Thank you.